So we've seen two methods of factoring using GCFs and then extending the GCF method to something called factoring by grouping. Our next goal is to learn how to factor trinomials. Trinomial is a polynomial with three terms like x squared plus x plus 1, x squared minus x minus 6, etc. To build an intuition of how to do it, we are going to start by utilizing our area analogy from before, except in the reverse direction. Now, let's say I want to factor x squared plus 3x plus 2. We can rewrite this as x squared plus 3 blocks of 1 times x, shown in green, and 2 blocks of 1 times 1. X squared can be interpreted as an area of this rectangle with sides x and x. Similarly, 1 times x can be represented as this green rectangle, sides 1 by x, and the blue ones is 1 by 1. Now, recall that the end goal of factoring is to rewrite x squared plus 3x plus 2 as two products, which means that we are trying to arrange these smaller rectangles to get a larger rectangle. Now, at this point, you can pause the video and try to see if you can stack these, how many? 6 rectangles, smaller ones, to get a large rectangle somehow. Here's the solution. You place the pink rectangle, 2 green rectangles on its right side, 1 green rectangle lying on the x on its width, and then the 2 small blue rectangles of area 1. And when I do this, I notice that the area of the big rectangle is just the length, which is x plus 1 plus 1, that's x plus 2, and the height, which is x plus 1, so it's x plus 2 times x plus 1, and you're done with the factoring. Right, so what you're doing is you're trying to find an arrangement of these smaller rectangles, so you end up with a bigger rectangle. Now let's look at another problem. X squared plus 5x plus 6. Now you have 1 pink rectangle, 5 green rectangles, and 6 blue rectangles. Again, go ahead, pause the video, and try and see if you can draw a picture where you arrange them into a single rectangle. You notice that some combinations don't work. For example, if I stack 4 of these vertically and 1 horizontally, I can fill in the 4 blue rectangles, but I'm still left with 2 more, which I cannot place anywhere without breaking the shape. But if you stack the green rectangles as such, meaning 3 vertically and 2 horizontally, then you make up exactly 6 spots where the 6 blue rectangles go in, and then you get the factoring as x plus 1 plus 1 plus 1, which is x plus 3, times x plus 1 plus 1, which is x plus 2. So the takeaway from this is that our process depends heavily on how we distribute the green rectangles, right? And how we distribute them horizontally and vertically, which in the algebra sense would mean the distribution of the x term matters, right? Remember, the green rectangles correspond to the x terms, so that matters. So the last observation, that how we distribute the green rectangles horizontally, vertically matters. In the example of x squared plus 5x plus 6, we noticed that what worked was that we placed 3 vertical and 2 horizontal, and that created 6 spaces. So essentially what I'm doing is I'm trying to find how do I distribute 5 such that the product of the distribution is 6. Because I had 5 of those green rectangles and I had to create 6 spaces for the small rectangles. Now by elimination, I start with 4 plus 1, but 4 times 1 is 4. That's not enough. Whereas 3 plus 2 gives me 3 times 2 is 6, which works. So you could also stack these in horizontally, vertically, 3 and 2. It amounts to the same thing, x plus 2 times x plus 3. How's the algebra going on here? Here's what the distribution corresponds to. The rectangles become 2x plus 3x, and then we use our old familiar method of factoring by grouping to get the expression x plus 2, or the factor x plus 2 and x plus 3, which is the same as what we got with the rectangles. Okay, now that we have the intuition, we are going to formalize the process. Now, to formalize the process, let's start with something that's factored, say x minus a and x minus b. And when we FOIL, you will see that the coefficient of x is actually the sum of the factor, and the constant or the last number is the product of the factor. For example, x squared plus 6x plus 8. Now what we are doing here is we are looking for two numbers that add up to 6 and whose product is 8. So a method to do that, a logical way to do that would be to start by listing the factors of 8. So you have 1 times 8, but that sum is 9. 2 times 4, the sum is 6, we're good. Which means I rewrite 6x as 2x plus 4x, and then I find the GCF and I do the factoring by grouping. Next example, x squared plus x minus 2. Here the sum is 1, but the product is negative 2. Now how can you have a product of negative 2 is you either have negative 1 times 2 or negative 2 times 1. In the latter, the sum is negative 1, so we ignore. And in the former, the sum is 1, so we rewrite x as negative x plus 2x, and then we are able to factor it. Let's factor 2x squared plus 5x minus 3. The presence of 2 here affects our method a little bit, but not too much. The sum is still the middle term, which is 5, and the product is 2 times negative 3. Now, this is how it changes is the product now is not just negative 3, but it also gets multiplied by the number in front. Now, negative 6 has factors, negative 6 and 1, whose sum is negative 5, negative 2 and 3, sum of 1, 2 and negative 3 with the sum of negative 1, and 6 and negative 1 with the sum of 5. So we select that. We break up 5x as 6x minus x, and we get our factor as 2x minus 1 times x plus 3. Some more examples here. So what you can do is you can pause at each point and try to figure out how to break the negative 14x. Some that I wanted to go over. One of the first one, factor of 8x to the 6 minus 10x to the 5 minus 3x to the 4. Now the first thing here is you can actually simplify the problem by observing that the GCF of the terms is x to the 4. So you can factor x to the 4 out, and then you end up with a familiar thing which you can use the method we just learned. In the next example, we use another method called substitution. So here we notice it's x to the 6. We let x cubed be u, then x to the 6 is u squared. So the equation becomes u squared minus 8u plus 15, which is now a more familiar situation. Sometimes you may have two variables. We can use the same method. So the sum needs to be negative 13, and the product needs to be 3 times 4, 12. So sometimes you may have to do a combination of substitution, taking GCF, and there might be two variables involved. So it's good to know all these tricks. That's it.